In this tutorial, I'm going to show you how to fit a simple linear regression model using R, as well as obtain the necessary standard errors and p-values for inference. So to start out, I want to work with a data set that's found in the Log5 data R package. So we'll need to install that, install.packages, and we'll put Log5 data in quotation marks to allow ourselves to be able to install that. Now I'm using RStudio, so no other windows will pop up. It will install this package from the appropriate R mirror. But if you're using a different version of R, then you may have to select your mirror site, and I recommend 0-cloud, which is run by RStudio and is updated quite frequently. Now that we have downloaded this package, I'm going to run this library log5 data command. Now notice that I'm typing everything up here in this editor. If you need to get a new editor, you can click on this top left icon and select R script in order to get a new R script so your work doesn't go away, because it does disappear if you work just down here in your console. And I've already typed my commands, but so I can highlight and then click run, and it will run that command. Now what happens here, if you go down here to the bottom right pane and click on packages and scroll down to the L's, what you'll see is that it has loaded the Log5 data set. So now that we can access all of the data sets that are in that R package. And to call a certain data set, I want to work with the student survey data, I just can run this data student survey command, and what that's going to do is pull the data set that I want into my working directory. So you can see now that I have this student survey object in my global environment in my top right pane. And if I click on that, it'll pull up a view of my data set so I can see what's in here. And what we're going to actually work with today are the SAT scores and the GPAs. So we can work with the overall SAT score, the math SAT score, the verbal SAT score. Let's work with the verbal SAT score here. And the GPA is the college GPA. So we're using that verbal SAT score to predict a student's college GPA. Now, before we go and fit a linear regression model, let's just plot our data. So if we want to do this, we can just use the command plot. Actually, let's load the mosaic package. So library mosaic. Let's run this line. Now I've already downloaded that, and we've already used that numerous times throughout the course, so there's no issue there. And now what we can do is we can do XY plot, and we want to plot GPA against verbal SAT, so that's GPA tilde, this is a tilde here, verbal GPA, data equal student survey. And now that I have this line completely written, I can click run, and it'll create this scatter plot here. And if we interpret this, we can see these gaps at the top left and lower right corners, so that would indicate that we have an overall positive linear association between verbal SAT and college GPA, though we can see that the relationship is not extremely strong because you have quite a bit of dispersion around this true linear form. So now what we've been talking about in class is simple linear regression, and in order to fit a simple linear regression model, we need to run a command like the one I've written here. So LM means linear model, so we're going to fit a linear model where we fit GPA by, so tilde means by here, verbal SAT. So this is our explanatory variable. In verbal SAT, GPA is our response variable, and we have to tell it where the data live. And then we'll click run. Now notice we haven't received anything out, so that's good. It means there haven't been any issues. So if I now type model and hit enter in my console, I'm just going to get the call, so basically what I just typed in order to fit this, as well as the coefficient, so I get my intercept and my slope. So if you really want information about this model, you need to look at the summary of the model. So if I now run that, you'll see that we get a lot more information. Specifically, you get some information about your residuals, the 5-number summary specifically. You also get some information about your regression coefficients here. So here you get the actual estimates, so this is your estimated intercept here at about 2.03. you get an estimate of your slope, which is 0.00189, and then you get the standard errors for each of these estimates, so you don't have to calculate them by hand. R will do that for you. Then remember, in order to run the hypothesis test that the slope is equal to 0 against the hypothesis test that it is not equal to 0, we would just divide our estimate by our standard error, and that's exactly what this t-value is here. And then R also converts this to a p-value. So this is 1.45 times 10 to the negative 11th power for our p-value, so it's quite small, very small. So we would reject the null hypothesis. Now, other pieces of information that R gives you the residual standard error, which just says, well, this is the standard deviation of my residuals. Additionally, if you look at this multiple R squared down here, this is R squared. It's called multiple R squared for when you get more than one predictor, but don't worry about that for now. If you need an R squared value, you can just go right down here. And that's all the pieces of the simple linear regression model that we've discussed. So now you're ready to go.